All right. Okay, we're recording. Here we go with 6-4. Okay, guys, so like I said last time, logs can be very simple if you know the rules. All you have to do is know the rules, okay? This right here, that box is how to convert. So the left is log and the right is exponential, okay? I want you to write, everybody write down 2 to the third. Okay, everybody write down 2 to the third. You have a base in that expression, and you have an exponent. So the base is the what? Everybody talk to me. The base is the 2, and the exponent is the 3. Inside the box, see that y equals? Write this down for me. Write down y equals log base b of x. That's how you say that. Y equals log base b of x. Okay, so here's the awesome thing. When you convert to log, from log to exponential, or vice versa, do you see how this is the base, because we called it base b? And then when you convert it on the other side, it's also the base. So b is the base in both ways, in both methods, okay? So here's how you go from log to exponential, guys. You write down that base, which is a b. You raise it to the other side, which is a y, is equal to, the only thing that I haven't written is an x, okay? When you go the other way, this is your base. So you go log base b of the other side, which is a y, is equal to, the only thing I haven't written is an x, okay? One more thing I want to say is this. If you don't have to write this down. If you have x equals 4, and then you add 1 to each side, x plus 1 equals 4 plus 1, those are equivalent statements. They both mean the same thing. They just look different, okay? So if you have this, you don't have to write any of this down. 2 to the b power is equal to 8. That's exponential. When I convert it into log, I'm going to write log base 2 of the other side, which is an 8, is equal to b. You guys, just like these two things right here are equivalent statements, these are also equivalent statements. That looks really bad, sorry. They're both equivalent statements. They both are saying the same thing. It just looks different. So it's exactly the same statement, just written in a different way, okay? All right, so let's do example 1 nice and slowly. I'm telling you, 80% of the log and exponential problems that you do require conversion. So if you can't convert, it's going to be devastating. And this is converting, okay? Look what you do. See how that base is a 5? Write that down. Raise it to the other side, which is a 2, is equal to, what's the only thing we haven't written down yet, guys? The x, right? So that's all you do. Okay, let's do this next one. Everybody tell me what number you write down first. Talk to me. The 4, right? Then you raise it to the other side, which is a 3, is equal to, everybody in the room, what's the only number we haven't written down, or the only thing we haven't written down? 64. In this case, it's a number. It won't always be. Okay, this one right here. Start with your base. Raise it to the, talk to me. Everybody talk to me. The second, yeah, other side is equal to 25. Now, sometimes people want to write this as like 25 equals 25, like they want to evaluate that. Don't do that, because if it doesn't have an exponent, then it's not exponential form. It's got to still have an exponent in it, okay? Everybody in the room, do question D. Do it on your own. Okay, I'm going to tell you what it is. Write down your 7, raise it to the other side, which is a 0, equals 1. Who says I got that? Let me see up high. Give me a big raise. Okay, good. Okay, now we're going to go the other way. Okay, so they give it to us in exponential, and they want to write it in log. So everybody write the word log. Up in part A, the base is the 6. So the 6 is the base down here. So that would be log base 6. Guys, that 6 is subscript, so it's lower. It's not on the same level as the log, and I'm picky about it. So make sure you do it subscript. Of the other side, which is a 1, is equal to, the only thing I haven't written is talk to me, 0. This is easy. Look at this one. Log base. You guys, there are 30 people in this room, so I should have 30 voices talking to me, okay? Log base what, everybody? Log base 5. Thank you. Of, talk to me, other side, 25, is equal to, what haven't I written? 2. Beautiful. This one. Log base, 35 people. 4. Of, other side, 16, equals, talk to me, x. Good. Next one. Log base, tell me, 3, of, other side, 1 over 81, equals negative 4. Okay, now look at that. There's nothing wrong with it. I don't love it, though, because what you're taking the log of is a fraction, and it's a little complex. So if it's anything other than, like, you know, just like a 2 or an x or something, I always just throw parentheses around it, because I think it's more clear that both the 1 and the 81 is what I'm taking the log of. Okay? All right, that was question D. Now we're going to find the log. Okay? So there's lots of different ways to do this. We're going to set this equal to x. Everybody just set these equal to x. Okay? All of them. And then we're just going to figure out what x is. So let's go to question A. I want you to write this down. Stuck. When you get stuck, you convert. If you had something like this, guys, just listen for a second. If you had y equals 2, you wouldn't be stuck because the y's not, you would be stuck because the y's all alone. If you had this, 2y equals 2, are you stuck? No, because you could do what, everybody? Divide by 2, right? So look at this guy. Log base 2 of 8. That's all one thing. So all I have over there is the log, so I'm stuck. It's not like I have this, guys. It's not like I have a 2 in front or 2 plus. In that circumstance, I would not be stuck, but I'm definitely stuck. So as soon as you're stuck, what you do is you convert. If you're in log, you put it in exponential. If you're in exponential, you put it in log. So I'm going to convert this. So my base is a 2. Raised to the other side, which is an x, is equal to 8. Then I want you to write the word think. You just think about it. 2 to what power gives me 8? Everybody tell me what it is. It is 3. That's your answer and you're done. Okay? This one right here. I'm stuck because the only thing on the left is the log. So I convert it. So I go 5 to the x equals 1. Then I want you to write the word think. You think about it. 5 to what power gives me 1, everybody? 5 to the 0. That's your answer. This one right here. 7 to the x is equal to 1 over 49. Now, this one is not as easy to see. I know that 49 can be written as a power of 7, right? So I'm going to write this as 7 to the x power is 1 over 7 to the second. 7 to the second is 49. I don't want that 7 squared on the bottom, so I'm going to pull him up to the top. So then I have 7 to the x equals 7 to the, talk to me, negative second. Now we're to last time's lesson. If 7 to the x is 7 to the negative second, then I know that x must be negative 2, and I'm done. Okay? Who says easy? I get all this. Raise your hand. Okay, great. Okay, this one right here. Let's convert it because we're stuck. So everybody go 8 to the x power is equal to the square root of 8. Now, when I taught you on Tuesday, I wasn't completely comfortable with you knowing what the square root of 8 was. I feel like there was hesitation. So look, 8 to the x power is equal to 8 to the square root of 8 is the same thing as 8 to the 1/2. Yes. So if 8 to this equals 8 to that, then I know x must be 1/2, and we're good. Okay? Do you have a question, bud?
No.
You good? Okay. Anybody else? All right, let's keep going. You guys are awesome. Grab your calculator, okay? Everybody grab that wonderful $10 calculator you've got. Okay, now everybody talk to me before I start pushing things. Listen, okay? If you have a log, look at question A, and there's no base right there, what's it assumed to be?
Log base.
It is log base 10. And if you look at your calculator, that is a log base 10. So if it just says log, then that's what I use, okay? So everybody go log 100 and hit enter. Okay? That's easy. It's a 2. You guys listen to this. I feel like I haven't emphasized this enough to you. You never, ever, ever round any answer unless, tell me, they tell you to round it. A rounded answer is an imperfect answer. So you never want to answer imperfectly unless you're directed to answer imperfectly, okay? So right here, whenever I don't have a good number, I'm going to say the directions tell me to go 4 digits, okay? ln, everybody freeze for just a second. What is ln? It's kind of all weird, right? It's just a log. It's log base E. And what is E again? We talked about it last time. It's not scary. 2.7, right? So it's not scary. It's like a pi. It's just a different number, okay? Do I really have to hit log base E? No, because there's an ln button right there. So everybody go ln 1.43, hit enter. We're going to round it to 4 digits. That's 0.3577. Never round unless instructed, because it's not perfect. Okay. Question C. Don't grab your calculator yet. If you did, it's okay. Does anybody know who hasn't touched their calculator what that's going to be equal to? Can you take the log of a negative number? You can't take the log of a negative number. And then you're like, why did she say log? Because that says ln. But is an ln a log? Yeah, it's just log base E. So ln has to follow the same rule as log because it is a log. You cannot take the log of a negative number. Please don't say, like sometimes I have people say error. Okay, well, yeah, your calculator gives you an error, but that's not it. So we're just going to say not possible. If you want to, go ahead and punch in ln negative 2.564 and you get error. Okay, okay, this one right here, this is log base what, everybody? Right here on E? Log base 10. So I'm stuck. When I'm stuck, I convert. So everybody go 10 to the 0.7482 is equal to x. Then go 10, caret button, 0.7482, hit enter, 4 digits, x equals 5.6002. There's my answer. So I just converted it. This guy right here, ln is log base E. So I want everybody to write log base E of x equals 1.335. All I did is replace ln with log base E because they are exactly the same thing. Now I'm stuck, so I'm going to convert it. So it's E to the 1.335 is equal to x. Now let's put that in our calculator. So everybody go second, then go down 2 buttons to ln, 1.335, close it, enter, and I get x equals, now this is weird, 3.79999. So 4 digits, 1, 2, 3, 4 goes right there. So the 7,999 goes to what, everybody? 7,999. You have to round that up to 8,000. So this is just 3.8. Okay. It's not necessary to put those zeros because zeros at the end of a decimal don't change the decimal. So I'm not worried about that. If you put them, that's fine. I'm never going to put them. It doesn't change anything. Okay. Who says gotcha? Let me see up high. Okay, good. I want to ask you a question. Listen for a second. Last time we graphed exponentials, remember they all had an asymptote at the same point. They all hit 0, 1. They all went right 1, up A, curved it up, bam, 20 seconds. Literally 20 seconds. Who agrees 20 seconds? I can graph that thing in 20 seconds. Who says, I understand that. It's so easy. I get that. Raise your hand if you're good with exponentials. Hey, now we're going to do logs, and logs are just as easy. It's another 20 seconds. You just have to know all of the requirements. You know how I listed those requirements on the side? Y equals 0, 0, 1, right 1, up A. Same thing over here, different requirements, okay? Grab your pencil, and I want you to dash right there. There's your asymptote. Everybody in the room, what axis does that red line cross? Talk to me. X or Y? Crosses X. So everybody go X equals. Where does it cross the x-axis? Tell me. 0 is correct. Okay. Look at the graph. Domain. Everybody in the room, tell me, what is the domain? Talk to me. 0 to infinity. How do I close my 0? With a parenthesis. Why a parenthesis? Never touches it, right? How about range? Range is Y. Start low, move up, everything. Didn't tell me how to write it. I'm going to do it the easiest way, all real numbers. X-intercept, it's right here. It is the ordered pair, 1, 0. Sometimes, listen to this awesome trick. Sometimes people get confused about asymptotes. So an exponential has a horizontal asymptote. A log has a vertical asymptote. Look how easy. Log begins with the letter L. L is vertical. So a parent log has a vertical asymptote. So you can always remember that way. Only if it's a parent though, okay? Okay, over here off to the side, here's what I want you to remember. Number 1, X equals 0. That's your asymptote. Number 2, 1, 0. It's always going to be on a parent. Up above that, write down parent. Okay? The other one is this. Look at your equation, you guys. This is log base B of X. Log base B of X. So the third point is right B up 1. That's all you have to remember. Okay? Look at the graph. I went right 2 up 1. So that equation must be Y equals log base 2 of X. How do I know it's a 2? Because I went right 2 before I went up 1. So that's got to be the equation. Who says gotcha? Let me see. Up high. Okay, good. We already talked about this. Log base 10 of X is just log X. ln X is log base E. We already talked about that. Okay, here we go. Log base 2 of X. Log begins with an L, and an L is vertical. So dash in a vertical. By the way, this is a parent graph. Look right here for 2 seconds. That is not a parent. I need you to understand the difference between a parent and not a parent. This is not a parent because my graph is shifted. What does a plus 4 do, everybody? Up 4, minus 1 does right 1. I don't have any of those transformations. This is a parent. So since it's a parent log, I know it's going to hit the point 1, 0. My base is a 2. So I'm going to go right 2, up 1, graph it in, done. But you can't get log and exponential mixed up. You've got to be able to visualize what that parent looks like, okay? Let's do a quick table, okay? Everybody write down Y equals log base 2 of X. Would I ever give you a table? No. The point of a table is to help you graph, and I just graphed it without even doing the table. So I'm not going to give you a table. If you get a table, this is like super awkward. Like, how do I plug points in? Log is a little awkward. Exponential, we're way more comfortable with exponential. So I'm going to have you convert this. Everybody go 2 to the y is equal to x. I want you to use that to plug the values of your table in. So if y is a 1, 2 to the first is a 2. If y is a 2, 2 to the second is a 4. If y is a 0, 2 to the 0 is a 1. If y is a negative 1, what is 2 to the negative first, everybody? 1/2. Yeah, the 2 comes down, change your signs, right? That's it. Okay, let's do this one. Y equals ln x. Off to the side, I want you to write down parent. And then I want you to write f of x equals log base e of x. Do you really have to write it as log base e? No, but I'm writing it for you so you can see what I'm doing, okay? I know it's a parent log. So here is my asymptote. I know it hits the point 1, 0. Everybody in the room, how far do I go right before I'm allowed to go up 1? Talk to me. 2.7. Yeah, it's not scary. Whatever that base is, 2.7. So go up 2.7, pardon me, right 2.7, and then up 1. There's your graph. Done. Let's convert it. Everybody write e to the y is equal to x. That's the conversion. Y is 0, e to the 0 is a 1. Y is a 1, e to the first is an e. You guys, what is e to the negative first? What's that? 1 over e. And that's good enough for me because I'm not even going to use the table. So I'm not going to spend a lot of time making it perfect. Okay? Okay, here's question 6. This looks a lot like what we did last time. Only now it's a log. Okay? Skip 1, skip A, skip B, skip C. We're going to go down to D. Okay? So my last equation is supposed to be f of x equals log base 3 of x minus 1 minus 2. I just wrote my last one first so that I don't have to keep scrolling up to see it. Okay? So I'm going to call this guy right here g of x equals log base 3 of x is my parent. Log begins with an L, so I know my asymptote goes like that. I know it hits the point 1, 0. Everybody in the room, how far do I go right before I can go up 1? 3. So 3, 1, draw it in, piece of cake. Everybody in the room, do we have a reflection? No. So the other orders, you're not going to lose points for doing them in a different order. I'm going to do the down 2 first. So I'm going to go h of x equals log base 3 of x minus 2, and then I'm going to write down 2. You guys, does moving down 2 change a vertical asymptote? Tell me. Yes or no? No, because it goes on forever anyway, right? Put your pencil on 1, 0, go down 2. Put your pencil on 3, 1, go down 2, curve it in, done. Don't put your asymptote horizontal. People start getting confused, so just be careful, okay? The next one is going to be right 1 because of that minus 1. Does moving a vertical asymptote to the right change your asymptote? Tell me. Yes, it does. So let's go right 1. Everybody go to the point right 1, down 2, go right 1. Then everybody go right 3, down 1, and then go right 1. So there you go. Okay? There's your final graph. Now let's go to ABC. Find the domain. You're obviously looking at the final graph. And they want it in interval form. Tell me the domain, everybody. It is 1 to infinity. Tell me how to close the 1 with a parenthesis. So it's 1 to infinity. Everything parenthesis because you're not touching the 1. Find all the intercepts. If they ever say find all the intercepts, I want you to write x-intercept, and then clear over here, I want you to write y-intercept, so you're differentiating. You guys look at the graph. Someone tell me my y-intercept. None. Don't leave it blank. Fill in the word none. On the midterm, If you didn't write your intercepts as ordered pairs, they took everything off. You guys all did, because I've always made you, so you all did, right? Plus you're awesome. So to find the x-intercept, you let y be 0. Is the x-intercept going to be clean? It actually is clean, but you can't really tell. It's going to be clean, but we can't really tell, and that's okay, because you guys can figure out it another way, okay? So look at the equation. Let your y be a 0, okay? So everybody go log base 3 of x minus 1 minus 2 equals 0. Now I'm getting a little bit ahead of myself, but I'm still going to do it. This might freak you out just a teeny weeny bit, okay? Look. This log base 3 of x minus 1 is all stuck together. I can't like divide by 3 or add 1. It's all one thing. Your brain sees this. Y minus 2 equals 0 when you look at that, okay? Everybody in the room, if I have y minus 2 equals 0, am I stuck? Do I convert right now? Yes or no? No. What do I do? Move your 2 over, okay? So now I have log base 3 of x minus 1 is equal to 2. Your brain must see y equals 2, because log base 3 of x minus 1 is one thing. Am I stuck? Everybody in the room? Yes or no? I am, because the only thing I have on the left is a log. I can't divide by 3 or add 1 or anything. It's just all one thing. So when I get stuck, I convert. So this is 3 to the second equals x minus 1. 3 to the second is a 9. So I have x minus 1 equals 9. Pull my 1 over. I get x equals 10. My x-intercept is 10, 0, and I'm done. Okay, who says gotcha? Let's see. Great. Then the last thing is easy. Find the asymptotes. Look at the red final asymptote. It hits the x-axis. Everybody tell me where it hits the x-axis. 1. Easy. This is just like last time, only different. Different graph, same idea. Okay? Okay, here is question 7. First of all, everybody look at this. This looks so bad. It looks scary. What can I do to make it look less scary? Rewrite it. So everybody write y equals negative ln x minus 1 plus 4. Okay? So, because mine negative ln x minus 1 plus 4. Okay, here we go. It's a y equals, so I can use y equals on everything. So everybody go y equals ln x. Underneath that, I want you to write y equals log base e of x. ln and log base e are exactly the same thing. Okay? Then I want you to write parent. Do you really have to write that log base e of x? Nope. But when I graph it, I want you to be able to see what I'm looking at. So that's why I did it. Okay, so this is a parent. So there's my asymptote. Hits 1, 0. I go right the base, which is 2.7, and then I go up 1. So it looks like that. Everybody look at that equation. Everybody in the room, all 30 whatever of you, do I have a reflection? Talk to me. Yes or no? Yes. Is it a reflection across the x or is it a reflection across the y? It's right in the front. Alphabetically, what comes to the front? X. So this is a reflection across the x-axis. And I want you to write y equals negative ln x. If you want to write negative log base e of x, that's great. If you reflect it across the x-axis, guys, look at that graph on the left. The top asymptote goes to the bottom goes to the top. There is no change on your asymptote. The 1, 0 is still 1, 0. The 2.71 becomes 2.7 comma negative 1, and now your graph looks like that. Okay? The other transformations, I don't care. What would I like you to do next so that I can grade your test fast? What do I want you to do? Up 4. up 4. The plus 4 is up 4, just like on the other ones. So everybody go y equals negative ln x plus 4. Does moving a vertical asymptote up change your vertical asymptote? Talk to me. No, it doesn't. So it's still the same place. Go to 1, 0, go up 4. Now this gets a little funny. You just have to be careful. Go right 2.7 down 1, then go up 4, 1, 2, 3, 4. It's just kind of awkward because you're not perfectly, you know, on a perfect point. Okay, the last thing you have to do is you have to go to the right 1. Does going to the right 1 change a vertical asymptote? Yes, it does. Notice every single graph I do my asymptote first. This is 1, 4. Everybody go to 1, 4 and then go right 1. Everybody go to 2.7, 3 and then go right 1. Draw it in. There's my graph. Done. Just as easy as last time. Just a different parent. That's it. Okay, who says I gotcha? Okay, listen right here for 2 seconds. Just kind of kick back for a second and listen. You know how we have this, guys? Y equals x to the second. And everybody knows that's a parabola that goes here, right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4, blah, blah, blah. Then we adjust it. And then you have y equals x to the third, and you know that's here, right 1 up 1, left 1 down 1, 2, 8. You have all those things memorized, right? You just have 2 more things you have to have memorized. One of them is y equals e to the x. So y equals e to the x has an asymptote right here, hits 0, 1, right 1, up, e, looks like that. It may not even be e, it might be like 2. The other parent that you have to memorize is something like that. Any number being there, okay? So that parent, you have to go, okay, I know I'm going to have that. I know I'm going to have that. I know I go right that number. I go up 1. There's that parent. So these are just parent graphs that you must memorize perfectly, just like you have those memorized perfectly. Who says, I understand? Let me see. Okay, good. All right. Another piecewise. Okay. Everybody write down y equals log base e of x. Okay. Yeah, okay, it's good. I changed it. Log base e of x. So asymptote hits 1, 0. Go right 2.7, up 1. There's your graph. 20 seconds. But that whole thing's not supposed to be there. The only thing that's supposed to be there are things that are smaller than 1. Okay, here's 1. Where's smaller? To the left. So everything to the right of 1 must go away. And if it is 1, it is on that, so I'm going to do a closed circle. And my circles are going to be very clearly open or closed. Okay? Now I want you to write y equals negative ln x. Now, you guys, I am an extremely visual person. So I want to see the parent. That's for me. If you can do it, remembering the parent and then doing the reflection, go for it. My brain needs to see it. That negative is in the front, so I know I'm going to reflect that guy across the x. So this 2.71 is going to be 2.7 comma negative 1. And it's going to flip my graph that way. Okay? But the only part of that graph that's supposed to be there is when x is bigger than 1. Here's 1. Bigger's to the right, so anything to the left I must get rid of. I have an open intersecting with a closed. This is now the 3rd time we've talked about that definitely means closed. Okay, so that's what your graph looks like. That's it. Who says gotcha? Let's see. Okay, good. Question 9 and 10. This is kind of long, isn't it? Question 9 and 10 has caused problems. Okay? Yes?
For example, so now we're going to
Say it again. Oh, I didn't go back. Yep, let's do it real quick. Thank you. Find the domain. Thank you, bud. Look at the final graph. The domain is 0 to infinity. Okay? Intercepts are going to be x-intercept, y-intercept. It's never going to cross the y-axis, so I'm going to say none. To find the x-intercept, I'm going to let y be 0. So everybody write down 0 equals 4 minus ln x minus 1. Yes, sorry, I was looking at I was wondering why I had people keep going, huh? It is 1. I was not looking at the final graph. I was looking at the second to last graph. Okay, so back to x-intercept, let y be 0. This is what your brain sees. Guys, you have got to see this right. Your brain sees 4 minus y equals 0. Have you solved up for y yet if you have 4 minus y equals 0? No, you're not stuck. I'm going to take this negative ln and pull it that way. So now I have ln x minus 1 equals 4. All I did is pull it over. And now I'm stuck. My brain sees y equals 4. So now I'm going to convert it. ln is log base e. So when I convert it, I have e to the 4th equals x minus 1. Pull the 1 over. X equals e to the 4th plus 1. That's my x-intercept. So I'm going to write it as e to the 4th plus 1, comma 0, done. Okay, look at the final graph. What's the asymptote? It hits the x-axis at 1, and I'm done. Okay, all right, domain. This is a sore spot. Some of my students have not been great at this, okay? Maybe find a spot and write this down real quick, okay? Domain. Number 1, when you're finding domain, what do you look for? How many things do you look for? Do you remember from the past? 2 things. What's one of them? X on the bottom. So everybody write fraction, like y equals 1 over x. What do you know about x? X what, everybody? Cannot be 0. What's the second thing you look for when you're finding domain? Even root. I think some people are like, I don't even know what even root means. Here's a root, even number in there. Okay? Like y equals the square root of x. Talk to me about that. X greater than or equal to 0. Yep, so we're going to say inside greater than or equal to 0. And right here, we're going to say bottom cannot be 0. Okay, now we have a third one. Here's what it is. If you have y equals log base 2 of x, or log base anything of x, as long as it's 1 or bigger, okay? Log base anything of x, the x must be, give me 2 seconds. X must be greater than 0. Okay, so you can't take the log of 0 and you can't take the log of a negative. It has to be positive. Okay, so come back over here. Find the domain. Don't have a fraction, don't have an even root, I do have a log. So what I'm taking, the log of must be greater than 0. So 4x minus 5 must be greater than 0. Can't be negative, can't be 0. So now I just solve it. 4x must be greater than 5. X must be greater than 5/4. That's your answer. They didn't tell me how to write it. That's sufficient. Okay. Who says I gotcha right there? Okay. Now, put some stars right here. And right down here, I want you to write usual. So usually, it's very simple and very straightforward. Okay? This one is more difficult, less common. Okay? Find the domain. I don't have a fraction. I do have a fraction, but the fraction's in the log. Okay? So I don't have a fraction. I don't have an even root. I do have a log. So what I'm taking the log of x minus 1 over x to the second plus 4x must be, what do I say here? Greater than 0. Everybody look at that. This is why it's tougher. It is. This is critical numbers type 2. Now, I don't have to get a common denominator or anything because that's all done, but there's still quite a bit more work than what's involved in part A. So why is it a critical number type 1? Because I have type 2 actually, because I have a fraction with an x on the bottom and an inequality, right? So everybody go x minus 1 over x times x plus 4. So my critical numbers are x equals 0, 1, and negative 4. I don't have to worry about restrictions on this because there's no equal sign anyway. Okay, so I have a negative 4. Far away from the negative 4 I have a 0, and right after that I have a 1. All my circles are open. Okay, and now I'm going to have to test. You guys listen. There's nothing squared or fourth or any kind of multiplicity. So it's just going to alternate, plus, minus, plus, minus, plus. I just have to find one of them, and then the other kind of fall into place. So I'm going to do a negative 5, and I'm actually going to put it right here. I'm going to do parenthesis, 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 parenthesis. I'm going to do a negative 5. So I'm going to go negative 5, store, enter, parenthesis, membar, enter, minus 1, close it, divided by parenthesis, membar, enter, x squared, plus 4, membar, enter, close it, enter, and I get a negative. Now, if this were a test or a quiz, I would not just go negative, positive, negative, positive. If it were my homework, I think I would. Okay? Just, you know, because it's going to. I would not assume so on a test or quiz. Okay, I'm looking for where it's positive, so that would be here and here. So my final answer is negative 4 to 0 with a parenthesis, union 1 to infinity. They talk off all the points with no union. Union means what? Everybody write this down. Union means, tell me. It does not mean and. It means or. So it's in this region or in this region are solutions. Anything that's in either regions. You could never put an and, because a number couldn't be in the left region and in the right region. That doesn't make sense. Yes? I would certainly hope not. And if they did, then I would put on my gloves and fight for you. But let's just try to put a U, and then we'll be safe. Okay? Okay, here we go. I gotta have a little motivation here. How close are we? Okay, we can do this. Oh yeah, we can do this. Okay, everybody look right here. If you have a highlighter, I want you to highlight that. That is one thing. Some people do this. Look, divide 3, divide 3. You can't do that. That's equivalent to this mistake. Everybody listen to this for 2 seconds. If you divided by 3, that would be equivalent to thinking if you had, let's say, 3 times x equals y, to divide by 3. Could you do that? No, the 3 is in there. It's trapped in there. You guys know you can't do that. This is the same thing. Okay? All right. So, up above that equation, I want everybody to write y equals 2. That's what you need to see. You don't need to write it. I just need you to see it. Once your y is alone, meaning once your log is alone, that's considered stuck, and so you convert. I want you to write down the word convert. Okay, everybody write 3 to the second equals 4x minus 7. That's the conversion. So now I have 4x minus 7 equals 9. Move my 7 over. 4x equals 16. Divide by 4. X equals 4. Who says gotcha? We're still not done. If the problem is given in log, you must check. If you don't check, then maybe you think 4 is an answer, but it doesn't really work out. Okay? Look what you're going to do. Everybody go log base 3, bracket 4 times 4 minus 7, close it off, equals 2. Now, I'm going to show you how to put this in your calculator. Okay? I have to show you, talk about another little piece in order to do that. Go off to the side and write down log base 2 of 3. Has nothing directly related to this problem. How do you evaluate log base 2 of 3 on your calculator? Does anybody remember? I'm going to tell you. It's log 3 divided by log 2. That's how you put it in. We're not even going to do it. I'm just going to tell you. Okay, so look at that yellow highlighted thing. This is how you put it in. It's going to be confusing to you, I think. So everybody watch. Everybody hit log. Look at this stuff right here. This is 4 times 4 is 16. 16 minus 7 is 9. So that's really going to be log 9, close it off, divided by log 3, close it off. If your base is not 10, that's how you evaluate it. Everybody hit enter. I got 2 equals 2. The problem checks out great. My answer is x equals 4. Okay, who says gotcha? Let's see. Okay, here's another one. We're stuck. When you're stuck, you convert it. Everybody write x to the second equals 64. How do I get rid of the squared? Square root. So I'm going to square root both sides. So I get x equals, what comes right after the equals? Plus or minus. Square root of 64 is 8. Everybody write the word check. And then I want you to write x equals 8. Because we're checking 2 things. So if we have to check 2 things, we have to show which one we're checking. Everybody write down log base 8 of 64 is equal to 2. Let's practice putting log base 8 of 64 in our calculator. Everybody go log 64, close it off, divided by log 8, close it off, enter. I got 2 equals 2. I want you to write 2 equals 2 and put a little check right there. I checked it. It's good. Now I want you to write log base, or put x equals negative 8 now, because I've got 2 answers. Log base negative 8 of 64 is equal to 2. Can you do that? No, you can't. Remember, this number right here has to be greater than 0. Okay? So you can't do that. So I'm just going to say invalid solution. My only answer is x equals 8, and I'm done. Okay, who says I'm good? I'm good, I'm good. Okay, great. Here's question E. It's not a log. It's an exponential. It's the same thing. You just convert it to a log. Instead of going from log to exponential, you go to exponential to log. It's the same thing. Take your highlighter and highlight that. That's all one thing. You can't subtract 1. You cannot divide by a negative 2. That's all stuck together. Up above it, I want you to write y equals 13. That's what your brain sees. You've got your base, you've got your exponent. You can't pull them apart. They're one thing. I'm stuck, so I convert it. So when I convert this, it's log base e of the other side, which is a 13, is equal to negative 2x plus 1. You could keep writing it log base e the whole time. I don't care. Or you could write it as ln. I'm going to write it as ln. So now I have negative 2x equals ln 13 minus 1. All I did is pull my 1 to the other side, and I wrote log base e as an ln. Everybody freeze. This is not a good idea. The way I wrote that, ln 13 minus 1, is not a good idea. Do you know why? What are they going to write? They're going to write ln 12. And the 1 has nothing to do with the ln. It's totally separate. So let's not even go there. Let's pull the 1 over and make it a negative, and let's write it first. So then we have negative 1 plus ln 13, and I'm not going to make that an ln 12. I won't make that mistake. Okay? Divide by a negative 2, and you get x equals negative 1 plus ln 13 all over -2, done. Do I have to check? You do not have to check. Why not? The problem did not have a log in it, okay? Would it be smart to check? Super smart, right? Store it in, plug it in, put it here, make sure you get 13, bam. Probably take you 30, 45 seconds. So I would check, but it's not required to check. Okay, here we go with this one. Stuck. Convert. Y to the -3rd equals 1/27. It's kind of awkward. Y to the -3rd is the same thing as 1/y to the 3rd. Okay? Then I'm just going to think about it like this. What to the 3rd gives me 27? Can you tell me? 3. Everything matches up perfectly. Therefore, y must be 3. Just write y equals 3. Do I have to check this guy? Yes, I do. Why do I have to check it? Everybody in the room, talk to me. Give it in log. So everybody go log base 3 of 1/27 equals -3. You know what happens, you guys? My students sometimes don't know how to put that log base 3 of 1/27 in their calculator, so they fake it. They get 3 equals 3, or -3 equals -3, and that really was not the right answer. They messed up somewhere. So if you mess up, your check's not going to work. If your answer's wrong and you say the check works, you just made 2 mistakes. The check is messed up and the answer's messed up. Who understands what I'm saying? Raise your hand. Okay, good. Just 1 second. Grab your calculator and go log 1 divide 27, close it off, divided by log 3, close it off, enter. I got -3 equals -3, and it really did check out. Okay, just make sure you really do check it. Question? Say it again. When I plugged it back in. Yeah. Okay. Okay, question E, I'm stuck. The reason I'm stuck is because the log is alone. So I'm going to write it as 9 to the -1/2 is equal to y. Can't have a negative exponent. So I'm going to write it on the bottom as a positive exponent. 1/9 to the +1/2. 9 to the +1/2 is the same as what? Square root of 9. What's the square root of 9? 3. So my answer is 1/3. Okay, check it. Write down the word check. Log base 9 of 1/3 is equal to -1/2. Let's check it. Leave the -1/2 and -1/2. See if I get a -1/2 on the left. Everybody go log 1 divide 3, close it off, divided by log 9, close it off, enter. I get -1/2 equals -1/2. It checks out fine. There's my answer. Who says I'm fine? I'm fine, I'm fine. Raise your hand. I got to see how we're feeling. You okay? I know it's a lot. I'm stuck. So I convert it. This is log base 10. So I have 10 to the 1st equals x minus 1 over 10. Okay, I just converted it. Log base 10 to the other side, which is a 1, equals x minus 1 over x. Put a 1 underneath it. Everybody knows that 10 to the 1st is just a 10, so I'm going to drop that. Then I'm going to cross multiply, because I have an equal sign in between. When I do that, I get 10x equals x minus 1. Pull the x over. 9x equals -1. Divide x equals -1/9. Write the word check. I write it log -1/9 minus 1 over -1/9 equals 1. Bless you. I'm going to store that -1/9 in because it's going to be so much easier. Everybody go -1 divide 9, store, enter. Okay, then I'm going to put the left-hand side in my calculator and make sure I get a 1. Everybody go log. Now, listen. Look at the x minus 1 inside. You have to tell the calculator the whole thing's on top, so I have to do parentheses right there. So I have to go log The calculator already puts a parenthesis for the log. I have to put another one. So I have to go parenthesis, membar, enter, -1, close it, divided by membar, enter, close it, enter, and I got 1 = 1. Please check. Otherwise, it's going to come time for the quiz or test 3, and you will not have practice, and you won't know how to put it in. Then you're going to have to fake it, and you might miss it. Okay? Okay, one more, 2 more. This one's super easy. Chemists use pH scale to test acidity. Here's the equation. Seawater has a pH of 8.5. Find H+. The hydrogen ion concentration is H+. So look what you do. You go into that equation, and where you see pH, you put in 8.5. So everybody go 8.5 equals negative log of H+. Don't get stressed out about H+. It's just a variable. It could be like an X. Stop right here. This is so important. Are we stuck? We are not stuck. Why are we not stuck? Tell me. The negative. The log is not alone. So now I have now I have log H+ equals negative 8.5. Right? Change both the signs. Now I convert it because now I am stuck. So 10 to the negative 8.5 is equal to H+, and we're going to leave it right there. That's good. Okay, this one right here. We talked about this last time. The normal healing of wounds is given by this equation. Remember, I accidentally had the point, same error right there. We start with 100. Everybody go A sub n equals 100e to the negative 0.35 times n. This is important. How many days will the wound be half of its original size? Everybody go n equals A sub n. A sub n is area in square millimeters, n is days. Watch. How many days? They want n. So n is going to stay in n. Will it be half of its original size? Half of its original size doesn't give me a number. My number is not 1/2. What is my number? Can you tell me? What is it? It is 50. Why is it 50? Started with 100, now we're 50. Okay? What am I going to ask you right now? Are we stuck? What's the answer to the question? Here is my base. Here is my exponent. Give me 1 more minute. Is there anything else on the right-hand side besides that? Tell me. There's 100, right? Can't be there. It's not part of it. So I have to divide. Don't pack up, okay? Everybody write e to the negative 0.35n is 50 divided by 100, which is 0.5. Now I'm stuck. Now I convert. So this is log base c, that's ln, 0.5 equals negative 0.35n. All I did is convert it. Now I have to solve it for n by dividing. So now I have n equals ln 0.5 divided by negative 0.35. Okay, I'm going to put that in my calculator so you don't have to. And I get n equals, if they told you to round it to 2 digits, it would be 1.98 days. This answer is so easily checked because if you store that exact number in and plug it in, you'll get it. Okay, everybody listen. I'm going to sit here right now and keep recording part B. If you want to stay, it'll take me another 1.5 minutes. If you want to go, I think you better watch it when you get home because you're going to be required to do it, okay? Freeze for 2 seconds. You cannot take those tests. You have to drop them on your way out, okay? Corrections are not due tomorrow, okay? They're going to be due like the middle of next week, so don't worry. Okay, I'm going to keep going. How long until it's 10% of its original size? So, guys, it was originally 100, okay? And I know they want to know time, how long, that's n. So what is 10% of 100? 10% of 100 is 10. So all they're saying is, when is it going to be 10 millimeters squared? Okay, I'm not stuck. Here's my base, here's my exponent. The 100, I still have to take care of that. So if I divide by 100, e to the negative 0.35n is 10 divided by 100 is 0.1. All I did is divide by 100. And now I'm stuck. So I convert it. So it's log base E of 0.1. That's ln 0.1 is equal to negative 0.35n. I just converted it. To solve for n, I get n equals ln 0.1 divided by negative 0.35. So now I'm going to go ln 0.1, close it off, divided by negative 0.35, hit enter, and if they told me like 2 digits, they'd have to tell me where to round, then it would be 6.58 days. You guys that are here, you're so awesome for staying here. Listen, I have this exact number. It is exactly is not 6.58, but if I stored my exact number in as x, and then I plugged it in right there for n, I better get a 10. So I can check this so fast. Just stick that thing back in, okay? Are you guys okay? Yeah, understood?